Welcome to this lesson on neutralization and pH curves. Things you need for today's lesson are graph paper, a pen and a pencil to annotate your graphs as we're going along. Just a quick recap that I'd like to go through. So you've got the pH scale above, as you can see. The pH scale is a measure of how acidic or alkaline a solution actually is. So the lower the pH of a solution, the more acidic it is. So from 0 to 6, you've got acidic substances. So pH 1, carboxylic acid, stomach acid, between pH 1 to 2. Then you've got approximately pH 3, you've got vinegar and your lemon juices. Then pH 4, you've got acidic rain. And then between pH 5 and pH 6, you've got normal rain. If we move on to 7, green, which represents a neutral substance, which can be pure water. From 8 to 14 are your alkaline substances. So your weaker alkaline substances would include washing up liquid pancreatic juice. Your stronger alkaline substances would be your salt powders, which is a pH 11. And then your strongest alkalies would be your bleach and your drain cleaners. So just bear that in mind. If we just move on to the challenge at the bottom, is a pH 0 acid more acidic than a pH 3 acid? Explain why. So the answer is yes, a pH 0 acid is more acidic than a pH 3 acid. The reason why is a pH 0 acid would contain a higher number of H plus ions, so a higher concentration of H plus ions. pH 3 would contain a lower concentration of H plus ions. Hence the reason pH 0 acid is more acidic than a pH 3 acid. So that would be worth a couple of marks in the exam if that was to come up. Just before we get started, I just want to go through a few things that you should already know. So remember, an acid is a substance that forms aqueous solutions with a pH of less than 7. Acids form H plus ions when they're in water. Also, another thing, an alkali is a base that dissolves in water to form a solution with a pH greater than 7. Alkalis form OH minus ions in water. So just remember that going forward. Now, there's two types of graphs that you need to know about at this level. The first one we're going to look at is the pH curve adding acid to an alkali. So we're going to look at adding acid to an alkali. So if you look at this particular bit here, pH curve adding acid to alkali. Now, if this comes up in the exam, you might need to actually draw this. So on your graph paper, I'd like you to scale, I would like you to plot a graph from 0 to 14 for the pH of the mixture. And at the bottom, you can go from 0 to 50 in fives for the volume of an acid. Please make sure you're quoting the units as you're going along. Now, let's get to the main bit of this particular bit. Now, this is a pH curve when you add an acid to an alkali. So at the top, as you can see, you have a high concentration of OH minus ions because at the top is a very, very strong alkali at the top. Now, as the curve is going down, the substance is still alkaline, but it's decreasing in pH number. So you could say from here, it's approximately at 13, it's going all the way down to about 10 here. Eventually, it carries on going to about 7, and then that will give us our endpoint here. Now, the endpoint, neutralization has occurred. At pH 7, the strength of an acid, the H plus and OH minus are equal concentration. So this is a particular endpoint. If the reaction carries on going as it does, then you can see the concentration of our H plus ions is increasing. This is the opposite, remember? So pH 5 and 6, you have a low concentration of H plus ions. As you start going further down, the concentration of H plus ions eventually increases, and the substance is now, as you're going along, becomes a lot more acidic. So please remember these points for the task, and you can annotate your graph as we're going along for this. Right, next task. This next task is another graph, another pH curve graph that you need to know about. So in the previous slide, we learned about when you add an acid to an alkali. In this particular scenario now, we're going to look at when a pH curve, when you're adding an alkali to an acid. So same procedure again, please. Please plot the graph using graph paper. Please make sure you're drawing it to scale using a pencil as well. Once you've done that, then I'd like you to annotate your graph. So if I just open the laser here and just go through some key points, when you're adding an alkali to an acid, you've got a high concentration of H plus ions. The substance is acidic, but the pH is increasing in number. So you got high concentration H plus ions, substance is acidic, but the pH is increasing. So as the pH is increasing, you're going to get lower concentration of H plus ions. Eventually you come to neutralization, which is the same for both graphs. Neutralization has occurred at pH 7. The strengths of the acid and alkali are equal, so you've got the same concentration of H plus and OH minus ions, and hence the endpoint. If we carry on going further across, the concentration of OH minus is increasing, the pH is increasing, and eventually the substance is now alkaline. So the further you get towards the top, the stronger the alkaline is going to be. So please annotate your graph with these notes. And thank you for listening.